Welcome back, you all. Today we are going to discuss few problems of game theory. Now I'm going to write one problem related to game theory. That is what. Suppose we have player B and strategies are B1, B2, B3, and B4. Strategy of player A is A1, A2, A3, and A4. The values are 3, 2, 4, 0, 3, 4, 2, 4, 4, 2, 4, 0, and 0, 4, 0, 8. And I told you earlier that first of all, we will find the we will find the saddle point. In first column, the maximum value is 4. So I am going to put a square on 4. In second column, maximum value is 4. So I am going to put a square on 4 on both value. In third column, maximum value is again 4. I am going to put a square on both value. In last column, the maximum value is 8. So I'm going to put a square on 8. Now, I'm going to put circle on a minimum value of each row. Like in first row, minimum value is 0. So I'm going to put circle on minimum value. In second row, minimum value is 2. In third row, minimum value is 0. In fourth row, minimum value is 0. So as we know that we haven't find a square and circle both together, that means there is no saddle point. If there is no saddle point and this matrix is 4 by 4, that means 4 rows and 4 column. That means this is a case of m by n. And what do we will apply law of dominance to reduce the dimension of this matrix. So I'm going to apply law of dominance. First of all, I'm going to compare column B with B1 with B2. And in this case, I found that 3 is greater than 2, but in second row, 4 is greater than 3. So we cannot apply law of dominance between B1 and B2. Now we are going to apply law of dominance between B1 and B3. So in this case, 3, 4, 4 is greater. 3, 2, 3 is greater. So again, it is not possible in this case. Now I'm going to apply B1 with B4. So 3, 0, 3 is greater, 3, 4, 4 is greater. Sorry, there is no option. Like now I'm going to apply law of dominance between B2 and B3. Let's check what happened. B2 and B3. If I'll apply in this between these two. 2, 4, 4 is greater, but 4 and 2, 4 is greater. Sorry, not possible. What about in B2 and B3? 2, 0, 2 is greater. 4, 4, both are equal. 2, 0, 2 is greater. 4, 8, 8 is greater. No, it's not possible. What about B3 and B4? If we will apply law of dominance between B3 and B4, what exactly happen? 4, 0, 4 is greater, 2, 4, 4 is greater. Sorry. So that means column wise it is not possible. If column wise law of dominance is not possible, that means we cannot reduce the dimension of columns. Now we are working on rows, like between A1 and A2, 3, 3 equal. 2, 4, 2 is lesser, 4, 2, 2 is lesser. No. If we apply this thing to A1 and A3, 3, 4, 3 is lesser, 2, 2 equal, 4, 4 equal, 0, 0 equal. Fantastic. When we will apply law of dominance rule between A1 and A3, we found A1 is lesser as compared to A3. A1 is lesser. So we will eliminate this row. We will eliminate this row. Because of in row, we will eliminate the row which has minimum value. Now we are going to apply law of dominance between A2 and A3. So 3, 4, 3 is lesser, 4, 2, 2 4 is, 2 is lesser. No. If we will apply law of dominance between A2 and A3, 3, 0, 0 is lesser, 4, 4 equal. 2 0 0 is lesser, but 4 and 8 4 is lesser. No. If we will apply a3 and a4, then 4 0 0 is lesser, 2 4 2 is lesser. No. That means what happened, we can apply, we can eliminate only one row, that is what, a1. Now again we will apply law of dominance between column. We are not going to consider the value of a1. Now just apply. 3 4 4 is greater, 4 2 4 is greater. No. 3 2 3 is greater, 4 4 equal, 0 0 equal. That means value of b1 is greater as compared to B3. So we will eliminate B1. Now compare B2 and B3. 4, 2, 4 is greater, 2, 4, 4 is greater. No. 4, 4 equal, 2, 0, 2 is greater, and 4, 8, 8 is greater. No. There is no column is eliminated. Now B3 and B4. In case of B3 and B4, 2, 4, 4 is greater, 4, 2, 4 is greater. That means we reduce the dimension of the matrix, and we found that ultimately after applying law of dominance, this is a case of 3 by 3. This is a case of what? 3 by 3 matrix. Then what we will do? There is one method that is known as average method, and with the help of average, we will apply law of dominance. And what exactly is that average method? You have to take it very seriously. Like what we will do, I'm going to take average of B2 and B3. I'm going to average of B2 and B3. So 4 plus 2 divided by 2 is 3. 2 plus 4 divided by 2 is 3. 4 plus 0 divided by 2 is 2. Now I'm going to compare average with B4. Average of B2 and B3 with B4. So 3, 4, 4 is greater, 3, 0, 3 is greater. No. That means there is no use of comparing average of B2 and B3 with B4. Now I'm going to take average of B4 and B2. And what is that average? 2, 4 plus divided by 2, that is 3. 4 plus 0 divided by 2 is 2. 0 plus 8 divided by 2 is 4. Now just compare. 4, 3. 4 is greater. 2, 2 equal. 4, 4 equal. That means the column B4, the column B2 is maximum or equal as compared to the average. So we will eliminate this column. We will eliminate this column. And remember this thing, we never eliminate the average. Remember this thing, we never eliminate the average. Right. Now what happened? I'm going to compare rows. Right. So 2 4 2 is lesser, 4 0 0 is lesser, 2 0 0 is lesser, 8 4 4 is lesser, 4 0 0 is lesser, 8 and 0 0 is lesser. Again, in these three rows we cannot eliminate anything, and so it is a case of m by 2. That means m rows and 2 column. You can solve it either on the basis of arithmetic method or on the basis of graphical method. But I want to try one more time. That is what? Average method. I'm going to take average of it. Average of A3 and A4. What is the average of it? 0, 4. Average is what? 2. 0 and 8. Average is what? 4. Now 2, 2 equal. 4, 4 equal. And I told you we can eliminate any row which has lesser or equal
lesser or equal value. But in this case, both rows, that means average row and A2, both are equal. So we can eliminate anyone, but we cannot eliminate average. We cannot eliminate average. That is why I'm going to eliminate this row. Right. So ultimately, what happened? The remaining matrix is what? B3 and B4. That is what? B3 and B4, and similarly A3 and A4. And values are what? Values are 4, 0, 0, and 8. This is the what? The 2 by 2 game payoff matrix. Now I'm going to come calculate the value of game. The difference is what? 4. The difference is 8. The difference is 4, and the difference is 8. So ultimately the total of the difference is what? 12. And the value of game, that is V, is equals to what? 0 into 8 is what? 0, plus 8 into 4, 32, divided by 12. That is, answer is 32 by 12. Right. If we're talking about the strategy of player A, because of A1 and A2 are not here, so we will take strategies what? 0, 0. And the difference in front of A3 is what? 8. So it is what? 8 by 12. Because of the difference in front of A3 is 8. That is why 8 by 12. Difference in front of A4 is 4. So it is what? 4 by 12. If we're talking about player B, B1 and B2 are missing in this matrix. So we will take what? 0, comma 0 for B1 and B2. Now B3 is what? Again 8 by 12 and 4 by 12. So ultimately answer is what? 32 by 12. So we can simply, V is equals to 32 by 12, and player strategy of player A is 0, 0. That is what? 2 by 3 and 1 by 3. Because of I simplify it. If you want to simplify it, you can make it simplify. Otherwise, it is not required. It is totally up to you. Examiner will consider 8 by 12 also, or 2 by 3 also. So this is about game payoff matrix, which doesn't have a saddle point. And when you will apply law of dominance, the law of dominance is directly not applied. So with the help of average method, we reduce the dimension of the matrix and we solve it. One more question I want to solve it, and sometime it is asked by examiner also. And what is that problem? Just a minute, I'll bring that problem. Uh, I'm going to delete it so that I can write it again. The new problem. Problem is basically we have player C and strategies are C1, C2, and C3, and another player R. Strategies are R1, R2, and R3. Values are 2, 4, 5, 10, 7, and Q, and 4, P6. Right. And what is given in this question? The given is what? Given is
value of game is equals to 7, and strategy of player C is 0 1 0, and strategy of player R is what? 0 1 0. That means this point is, this 7 is known as saddle point, right? This 7 is known as saddle point. It is given, and what we have to find the range, find the range of P and Q. We have to find the range of P and Q, right? uh, we know it that in column 2 7 is a value of game, and in column wise we put square on a maximum value. That means 7 must be maximum. If 7 must be maximum, then what's the value of P? So in that case, value of P must be either lesser or equals to 7. Suppose value of P is 5, then we can put a square on this. P is equals to 6, then we will put a square on this. P is equals to minus 3, we will put a square on 7. P is equals to 7, so we can put a square on 7 as well as P, right? But if P is 8, that means more than 7, so this square shift from this place to P. So that become wrong, because of answer is what? Saddle point is what? This 1 comma 1, first row, second row and second column, right? So this is our saddle point. So the value of P must be either lesser or equals to 7. If we're talking about the value of Q, because of in second row we will put circle on a minimum value, circle on a minimum value. That means 7 must be minimum. Then what is the value of Q? That means value of Q is either greater or equals to 7, greater or equals to 7. So this is the range of P and Q. So although it is very simple question, but sometimes we are not able to solve, or sometimes we are not able to focus on it. If we don't have how we will proceed it, how we will consider it, how we will deal with it, we cannot solve it, right? So this is another case. I want to discuss one more case that is also a very fantastic case. Just a minute, I'll bring that case for you. Uh, I don't know why we are very much, afraid from variables. When we saw variables now, we are not feel comfortable. So similarly, there is one question I want to just a minute, right? Right. So this is the question. Suppose I'm saying that there is player Y and strategies are Y1, Y2, Y3, and player X strategies are X1, X2, and X3. The values of the game payoff matrix are A4, A4, A3, and again A3, A1, A6, and A5, and A2, A2, A4, and A3. And one more information is given, that the relationship between A1, A2, A3 is like this. A1 is more than 0, A2 is more than A1, A3 is more than A2, A4 is more than A3, A5 is more than A4, and A6 is more than A5. So this relation is given. And the another thing which is given, that which we have to prove, that is what, uh, that x3, that is what, x3 is equals to y2. x3 is what? That is x3 strategy of player x, and y2 strategy of player y. Both are equals to 0. Both are equals to 0. We have to prove it. And second, what we have to prove it? The second which we have to prove it, that value of x1 is more than half. Value of x1 is more than half. The number 3 which we have to prove it, that value of game is less than a4 and more than a3. We have to prove it. And how we will prove it? What I'll do, I am considering, I am suppose, or we can say take a1 is equals to 1, a2 is equals to 2, similarly a6 is equals to 6. So ultimately what happened, our matrix become like this: 4, 3, 3, 1, 6, 5. Because of I am assuming a1 is equals to 1, like a6 is equals to 6, a2 is equals to 2. So what happened? I convert my variable into values. I convert my variable into values. So this is what it is, 3, right? And it is x1, it is x2, and it is x3, it is y1, it is y2, and it is y3. What we will do? We will do one thing. First of all, we find the saddle point. The maximum is 4, maximum is 6, maximum is 5. I request you, each and every person, that first of all you have to find saddle point in game payoff matrix, right? Without checking the game saddle point in the game payoff matrix, you will not proceed further, right? It happens many times there is a saddle point, but what we will do, we will proceed without checking the saddle point. So there is no saddle point. Now we will apply law of dominance. 4, 3, 4 is greater, no, and 6 is greater, 9. So now we are going to compare y1 and y3. 4, 3, 4 is greater, 3, 5, 5 is greater, no. Now y2 and y3, 3, 3 equal, 6, 5, 6 is greater, 4, 3, 4 is greater. Ultimately y2 is dominant, right? So now I'm going to compare x1 and x2. 4, 1, 1 is lesser, 3, 5, 3 is lesser, no. X1 and x3, 4, 2, 2 is lesser, 3, 3 equal. Ultimately the lower values, that means x3 is eliminated. So what remains, what matrix remains, that is what it is x1, x2, y1, y3, and values are what? 4, 3, 1, 5. Now you just solve it and find the value of game. This is what difference is: 4, difference is 1, difference is 2, difference is 3, difference total is what? 5. So value of game V is equals to 3 4s are 12 plus 5 1s are 5 divided by 5, that is 17 divided by 5, that means 3.4. That is what? 3.4. So it is value of game. Value of game is 3.4. Remember this thing. What we received? V is equals to 3.4. Now we are talking about the strategies of player X. Because of X is what? 4 by 5. 4 by 5. X2 is 1 by 5 and X3 is 0. If we're talking about player Y, Y1 is 2 by 5, 0 and 3 by 5. So ultimately what happened? Our first assumption, which we have to prove, that is what? X3 is equals to Y2 is equals to 0. It has proven because of X3 is 0, right? And y2 is 0. So it is proved. The second is what? That is x1 is must be more than half. Definitely x1 is more than half. X1 is 4 by 5. That is more than half. So it has been proved. The number 3 which we have to prove, that is what? Value of game. Uh, that is what? Value of game is lie between A3 and A4, and we assume that A3 is what? 3. A3 is what? 3, and A4 is what? 4, and our value of game is what? 3.4. So my value of game is lie between 3 and 4. So we prove all three assumptions, all three statement which we have to prove it, right? So it is, we discuss some typical problem which may ask in examination. I hope so. It is clear to each and every person who are watching this video, who are attending this class.